Dear students, now I'm going to tell you some words about the robot calibration. Each drive of the robot needs to know where is zero. This is the point from which the drive can calculate, can measure its angular rotation. So the robot has 6 drives and it has 6 places for calibration. Yes, 6 calibration nests. So now I will show you those places. This is the calibration of the first drive. This is calibration nest of the second drive. This is for the third drive. Here you can see a kind of hill or kind of elevation with a groove, and this is the most important place for the calibration. If this part is exactly in the lowest place of the groove, it's 0. You can observe it yourself. Here is the beginning of the wrist, and this is the calibration place of the fourth drive. And this is the calibration nest for the sixth drive. If the ring is rotating inside the mechanism, we cannot see the heel here. This is outside here and we can observe it, and here it's hidden. If it rotates, the user needs to find the groove of this specific place. Yeah? And he cannot observe it. He can only observe the tool which is attached here. Okay, so let's come back to the drive number 5. One of the robots is older one, and it has the calibration nest here. So this is the wrist, yes. And this is not convenient because if we attach the tool here and we will not remember to remove it after calibration, the tool can be broken if the will rotate in this direction, and here will be tool. The tool will move here, and in this case it will be broken. So in newer robots, the calibration nest of the fifth drive is in another place. So this is our newer robot, and the calibration nest is here under this cover. If we remove it, you can see here the place when you can connect the measuring tool, the calibration tool. And here is the hole for the inserting the tool, and here is the heel with the groove. Yeah, and if we insert here the tool, yeah, this is the heel, and if we here insert the tool, now in this case it's at pen, the skewer goes out here and can fall exactly down in the groove. If we remove the tool, the skewer will come back. Yeah. So this goes out only for the calibration process. And here you can see the tool which is applied to the robot. And here is it's very precise. One rotation is equal um, movement of 1 millimeter of this skewer. And we are trying to find the groove in this heel. Yeah. If the tool is not applied, if the tool is not applied, the skewer is hidden, and if we apply the tool, the skewer goes out. Yeah, here you can see exactly how it looked like, and you can see here the marks of the skewer. Each calibration nest has also such a large white, usually white marks. And here is one, and here is the second. And we can align them like this. And we should remember that in this case, the robot drive is not exactly at D0. Yeah. This configuration is the beginning of the searching of the zero. Yeah, we should start searching zero from this configuration. And this is the third drive. And we will find zero if we move this arm up. So we start with the large signs aligned, and we move this arm up, and then we find zero. Why it is so? Each drive has its specific direction of the zero searching. It is because of the backlash reduction. If we move this arm up, the backlash is reduced. If we move it down, the position of the drive is not precise. Yeah. Because the gear of the drive, the harmonic drive, has also a little backlash, and the measurement of the angular position is not precise because the resolver is here on the directly on the drive, and after it is a gear, yeah, which can have a backlash. So if we move it up, we reduce the backlash. So we should not, if we are searching the 0, we should not move a bit up and then down, and then once again up, and once again up, down. No, we should continuously move up and stop exactly at 0. Yeah, we cannot move down. If yes, we should move down significantly, yeah, and start all the process once again and try to stop exactly at 0. Okay, so how should we interpret the measuring tool? Let's assume that this elevation, that is hill, is moving left, and the measuring tool is static. Don't move left and right. So if this hill will move left, the stick will move up, and the tool will rotate clockwise. Okay, and if the stick goes down, the tool rotates counterclockwise. So we are looking the lowest place here. So the clock hand will move left when the stick falls down, stop here, and then we'll start to rotate right, clockwise. And we need to find this moment and stop the robot at this moment. When we stop the robot at 0, we can verify if it is correctly calibrated. So we can choose menu monitor, rob position, axis specific. And we can observe the value of angle in the drive which we are currently calibrating. So in our case, it would be drive number 3, and at 0 here should be exactly 90 degrees. If there is another value, we can perform the calibration. So we choose setup unmaster, and we need to destroy the calibration first. So unmaster, and here we can choose the axis which should be unmastered. So we select one of them and press unmaster. We need remember that the axis 4, 5, 6 are mechanically dependent. So if we unmaster axis number 4, we need to master 4, 5, and 6. So be careful, we will not calibrate the wrist. Usually we will calibrate axis number 3. So after unmastering, we can choose menu setup, master, and here are two options because there can be two different calibration tools. We are using the first one, so we choose deal. And in my case there is no axis to master because I didn't unmaster anything. And yeah, if there will be an axis for mastering, you can choose it and press master. That's it. Simply you choose the axis and press master, and the robot know where is its zero.